Hello, Jai Jagannath. How are you? I am Savajiro, very much excited to explore chemistry lab with you. So let's start today's lecture, reaction mechanism, lecture number 2. So let's start. So basically, in previous lecture, we discussed about what is reaction mechanism, that is, what is the real definition of reaction mechanism and how it proceeds. That is, what are the involvements of reaction mechanism, that is, what is substrate, what is nucleophile, and what is the medium, that is solvent medium, and how the product is formed. And here we discussed one thing, that how the nucleophilicity or the strength of nucleophile depends on the substrate as well as nucleophile, and how and what types of solvents are there. That is, solvents is two types, polar aquatic and polar aquatic. So we discussed everything details in previous lecture. So who have not seen or who have not watched the previous lecture, so let's go to HB Hub channel, then see it, and after clarify you go to this part 2 lecture. Okay, so basically if we take a recap, so let's start. This is substrate and this is nucleophile, and the medium is solvent medium. So why solvent medium is given? So solvent medium is given to make the reaction more feasible, then it forms a product. This is product, and this is the living. So it is the basic mechanism of a substitution reaction. So one nucleophile comes and substitutes in the position of X and leaves it out. So X is leaving group. So basically, previous lecture we discussed about what is substitution reaction and what are the types of substitution reaction. So substitution are of mainly 6 types. SN1, that is unimolecular substitution reaction. SN2, that is bimolecular. SN1 means unimolecular substitution reaction. SN2 means bimolecular substitution reaction. SNI means I for intramolecular substitution reaction. Then SNNG, that is neighboring group participation substitution reaction. And other two types are SNAB and SNPA. These two reactions basically occur in aromatic substitution reaction. One is nucleophilic aromatic substitution reaction, one is electrophilic aromatic substitution reaction. And basically in SNEA means this is benzene mechanism. What is benzene mechanism? We will discuss in upcoming lecture. So you know that reaction mechanism is of 6 types. Okay. So let's start. What is SN1 and what is SN2? In this lecture, we will mainly discuss about SN1 and SN2. So let's start the main part of SN1 and SN2. Okay. In SN1 reaction, that is in unimolecular substitution reaction, these are the basic points. SN1, the superscript 1 means this is unimolecular reaction. Unimolecular means this reaction depends on only one substrate. That is, if we will write the rate law, the rate proportional to the substrate. It doesn't depend upon nucleophile. So that H, it depends upon only one molecule, that is substrate. So it is unimolecular reaction. So if we will write the rate law, then rate proportional to substrate, and write rate equal to K into substrate. So K is rate constant. Okay. Then come to second point. H, it is unimolecular reaction, but it passes through 2 steps. That is, one is intermediate formation and second one is attack of nucleophile. The intermediate formation is RDS, that is the slow step. That is rate determining step. It is RDS step. In this step, mainly intermediate form, that intermediate is carbocation intermediate. Okay guys, this is carbocation intermediate. And in the second point, that is the second step, attack of nucleophile. After formation of carbocation, then the nucleophile attacks to the carbocation point. So how this reaction proceeds? Basically, it is a alkyl halide substrate. Okay. At first, the step 1 is step 1. In this step 1, at first lipid group leaves out, that is X minus leaves out, and it is formed a carbocation intermediate. Carbocation intermediate is the RDA step. This is the RDA step. That means it is slow step or it is called as rate determining step. In this carbocation, you know that this is sp2 center. This is sp2. How do you mean by sp2? sp2 means planar in nature. Planar in nature. So this is vacant p orbital. How now? What do you mean by vacant p orbital? Here is a confusion arises, I know. So it is carbon. Carbon atom number 6. If we will write the electron configuration 1s2, 2s2 and p2. In this p subcell, there is 3 orbitals. One is px, one is py, and one is pz. So 2p2 means here is 2 electron. So one is px, one is py, and the pz is vacant. So that to this vacant p orbital, the upcoming nucleophile will attack. So there is 2 chances that nucleophile may attack from above the side or to below the side, because you know that sp2 center is planar. Planar means this side. So here is a chance from attacking from above the side and from below the side. So that if nucleophile comes from above the side, then it will form nucleophile above R1, in wedge for which R2, and in S for which R3. That means you check decision configuration, and the similar configuration we will find there. That means it is retention product. There is no change. So it is called retention. Retention configuration. And if you will attack, the nucleophile from below the side, then nucleophile comes below. So similarly here, nucleophile comes from below. That is nucleophile, and this is R1, here you check the nucleophile is below, that is it is inversion in product. See, inversion in product. So write everything. So here this is step 1. That means it is slow step, rate determining step. From this step we may conclude or we may know that how the stability of carbocation. That means the more will be the stability of carbocation, the more will be the SN1 reaction. If we will check the carbocation stability is more, that means SN1 reaction will be fast. That means we may conclude that stability of carbocation direct option to SN1 reaction. That means if the stability of carbocation increases, that means the more will be the SN1 reaction. So in this SN1 reaction, in this case, basically the solvent is used polar protic solvent. Why polar protic solvent? Here is a question. Why polar protic solvent? Polar protic means it must have hydrogen, which is attached to most electronegative atom. That means polar protic solvent. The polar protic solvent is used to stabilize the intermediate carbocation as well as the living group. Like if here is like water, it is a polar protic solvent. If the longer oxygen, it will stabilize the carbocation by coordinate. Okay, and the living group, it will coordinate with hydrogen. It will also be stabilized, so that the polar protic solvent is used to stabilize both carbocation as well as intermediate. So let's start. What is stability of carbocation? Let's start. In SN1 reaction, the substrate type is basically 3 degree, then 12 degree, then 1 degree, then methyl. So why 3 degree is more stable than 2 degree? So if the carbocation and either the methyl group. Okay. So this carbocation is stabilized by 3 methyl group or 3 alkyl group by their inductive effect or their hyperconjugation. So which can stabilize the carbocation. Okay. So basically in this diagram, one is the step 1. Step 1 is carbocation formation. Step 1 is carbocation formation, which is ideal step. That is rate determining step, which is also slow. Then step 2. In step 2, the nucleophile attacks. The nucleophile attacks from above the side or from below the side. There is two types of possible of attacking nucleophile. So it is mainly assembly mixture. That means one will for retention product and one will for inversion product. So that it is assembly mixture. If you will draw the energy profile diagram, that is how the SN1 proceeds. How the SN1 proceeds. If you will diagram, if you will make the diagram, let's see. This is the energy and this is the reaction coordinate. This is reaction coordinate. And the reactant will here begins. So you know that H, the energy of reactant, H, the energy of reactant is more, but the product energy must be less than reactant, so that a reaction proceeds from reactant to product. Okay. If you will diagram the energy profile diagram, first this comes in transition state. This type, this is transition state 1, and this is the intermediate formation, that is carbocation intermediate. Then transition state 2. This is transition state 2, and this is the product. If question comes that how many number of transition state and how many numbers of intermediate, then there is a formula to know that transition state equal to number of intermediate plus 1. H, here is the intermediate 1, that is carbocation, so that the transition state 2. Intermediate is 1 plus 1 equal to transition state. So that there is two types of transition state 1, then transition state 2. Okay. So here we complete the SN1 reaction. Let's come to second part, that is SN2 reaction. How SN2 reaction proceeds. Let's come to SN2 part, that is bimolecular substitution reaction. Bimolecular means it depends upon two molecules. So if this is substrate, we will write the rate. The rate proportional to substrate divided upcoming nucleophile. And if we rate equal to a constant, and this is substrate and nucleophile. And this is 1. So H, it is 1 plus 1 equal to 2. That means bimolecular. So H, the SN2 reaction depends upon substrate as well as the nucleophile. So it is bimolecular in nature. So it is bimolecular substitution reaction. But it proceeds through single pathway. Then how it proceeds? Let's check. If this is a carbon, if here coming in here is a nucleophile. So in this case basically the nucleophile attacks the antibody, the sigma antibody of carbon leaving group. That means here is a antibody, sigma antibody present. It is sigma antibody present. So the upcoming nucleophile will attack the back side of CX, back side of carbon leaving group. So this is the sigma antibody. To this point the nucleophile will attack. Okay. So if you will check, this is ethyl and this is hydrogen and this is methyl. X and this is the nucleophile. So you know that it is a TBB structure, that is trigonal bipyramidal in nature. TBB structure. In this type of reaction, you have to remember that It is a concerted reaction. What do you mean by concerted reaction? Concerted reaction is that is the reaction which is completed in only single step. That means at a time you see the nucleophile will attack. That means the formation of carbon nucleophile bond. At the same time, the carbon and lipid group is broken down. So that it is concentrated in reaction. Then it will form carbon. Here is the nucleophile. And here it is, and here hydrogen, and here oxygen. So you know that here you notice that totally the product, so the reactant and here is the product. So here mainly inversion takes place. That means the stereo part of this reaction is inversion. That is the product is inversion in nature. The product is inversion in nature. Okay, so write this part. Basically, if the nucleophile will attack, the sigma antibody of carbon living group or carbon X bond, so then inversion product form. So you think if we will increase the steric hindrance, then the attack of nucleophile with the carbon antibody, that is the CX antibody, sigma antibody, then the nucleophile decreases. So if we will steric hindrance increases, then the attack of nucleophile decreases. So in SN2 reaction, basically, if we will decrease the steric hindrance, then the attack of or the strength of nucleophile will increases. That means less the steric hindrance, more the SN2 reaction. So the order will be that is the substrate order will be methyl, then 1 degree, then 2 degree, then 3 degree. Okay guys, so basically here mainly polar aprotic solvent is used. Why polar aprotic solvent? You know that in SN1 case polar aprotic solvent is used, but here SN2 reaction polar aprotic solvent is used because the polar aprotic solvent increases the nucleophiles of a nucleophile, that is the strength of nucleophile. Okay, so basically the inversion product will be formed, which is the addition inversion. Here the CX bond is in the right side and the carbon nucleophile is the left side. So that the inversion product will be formed. So if you will draw the transition state diagram, let's see. The transition state diagram will be, this is the energy coordinate, and this is the reaction coordinate. So here is the reactor, and here is the product, and this is the transition state. H, here is no intermediate formation, so the only transition state equal to 1. So here only transition state 1. Okay. So how we will know that this reaction will follow SN1 or this reaction will follow SN2? So let's do examples. Okay. So let's do this problem. So you know that this is a 2 degree alkyl halide, and here is given H2 and here is given OH minus. So first come to the left side. So here is the nature of water. What is the nature of water? This is neutral in nature. So as it is neutral in nature, then it will follow SN1 mechanism. Why SN1 mechanism? You know that in SN1 mechanism it is unimolecular substitution. That means it depends upon only substrate, not the concentration of nucleophile. So as it is neutral, then it will follow SN1. So in SN1 mechanism, at first the lipid group is left out. So lipid group is out. Then it will form a carbocation intermediate. So this is a carbocation intermediate. This is carbocation intermediate, and here is the vacant here orbital. So the attack of nucleophile from above the side or from below the side. So if the non-pair will attack, H2 will attack from above the side or from below the side. So there is two chances or two possible of product. One is retention, one is inversion. So if H2 will attack from above the side, then it will follow retention product. This is retention product. And if you will attack from below the side, then it is inversion product. That means this is unfortunate product. And in the last step, the D potential will occur. The D that is H plus will remove out. H plus will remove out. OH. So in this step also D potential will occur. Here minus H plus. And here will be the oxygen. So you know that here bromine is above the plane. So here the attack of nucleophile will be above the plane. So it is retention end product. So it is retention. It is retention. Then H it is the nucleophile is below. So it is inversion end product. It is inversion end product. So H two types of product are found. So that it is racemic in nature. So it will be 50% and it will be also 30%. So racemic in nature. Come to the OH minus. So you know that the nature of OH minus is very strong. That means it is very strong or strong nucleophile. It is strong nucleophile. So you know that in SN2 reaction it is bimolecular. That means the rate of reaction depends upon both substrate as well as the concentration of nucleophile. So as it is SN2 reaction, the product will be inversion in nature. So OH minus will have the antibonding. It is the carbon proton antibonding, sigma antibonding. So here OH minus will attack to the antibonding nature, so that the OH will be below the plane. The OH will be below the plane and it will be over. So it is inversion end product, 100% inversion end product. Okay, so this is the basic difference. How you will differentiate what will be the SN1 reaction and what will be the SN reaction and how it proceeds. So I will trick also I will apply in this video. So it is a basic information. If we will do much and more problems, then you will know that. Okay. So let's do more problems. So let's do problems. Some problems. Okay. Here is the question. So compare the rate of reaction towards SN1. Towards SN1. SN1 means unimolecular substitution reaction. So in this process, first remove the living group. And make the carbon intermediate. So here only one phenyl group. Here only one phenyl group. Here two phenyl group. Here two phenyl group. And here three phenyl group. Similarly, I will write three phenyl group. So you check here. This carbocation will stabilize by only one phenyl group by resonance. But here by two phenyl group, it's here more resonance, and here three phenyl group. That means it will make more and more stable the carbocation. So the order will be in decreasing order: 3, then 2, then 1. Okay, understand? That means here three phenyl group will stabilize the carbocation through the resonance. So it will be more stable. That means it is. I said that the carbocation stability is proportional to SN1 reaction. The more will be the carbocation stable, more will be the or faster will be the SN version. So come to second question. So it is a 3 degree alkyl halide, it is 2 degree alkyl halide, and it is 1 degree alkyl halide. So first remove the living group and make formation of carbocation. And if you will do carbocation formation, here C3 methyl and here methyl. So in this case, you have to check the number of alpha hydrogen. What do you mean by alpha hydrogen? That means it is a carbocation. So the carbon which is directly attached, to the carbocation, that is alpha carbon. And the number of hydrogen attached to the alpha carbon, these are the alpha hydrogens. So here one is alpha carbon, here second alpha carbon, here third alpha carbon. And in 1, 2 and 3, these 3 alpha carbon has 9 alpha hydrogen. And here you check, here C3, here C3, and here fixed charge. That is here 3 plus 3, 6 alpha hydrogen. And here you check only 3 alpha hydrogen. Only 3 alpha hydrogen. That means here is a concept: more will be the alpha hydrogen and more, that is more will be the carbon stability. That means the stability of carbon, the stability of carbon that was equal to number of alpha hydrogen. This is also a concept. That means more will be the alpha hydrogen, more will be the stability of carbon atom. So here 9 alpha hydrogen, here 6 alpha hydrogen, here 3 alpha hydrogen. What will be the order of second question? So here it will be 1, then 2, then 3. That means here 9 alpha hydrogen, so it is more stable. Then here 6 alpha hydrogen, then it comes after 1. Then it is 3 alpha hydrogen, so it comes after 2. So the order will be first, then second, then third. Okay, so let's do all two questions. So let's do third question. In this question, it is 2D alkaline, it is 1D alkaline, and it is also 1D alkaline. So you may think that 2D alkaline will be more stable. That means it will proceed by SN1 more speed, but not. Here is a concept. After removal of leading group, you check the intermediate stability. So here it is 2D carbon, here 2D carbon, and here you check, here 3 alpha hydrogen, here 1 alpha hydrogen. So total number of 4 alpha hydrogen. And here no alpha hydrogen, but here the oxygen atom, which is directly attached to carbon atom. That means it will stabilize the carbon atom through its measuring effect. That means it is non-dead, so it will stabilize the carbon atom by its measuring effect. Then it is 1D carbon atom also, and here is 3 alpha hydrogen. So you think which will be more stable? So I have a trick. Will you apply? Let's take a trick. Have you ever listened? Amri Hospital? Amri. That means A-M-R-I and hospital. Only exchange 2 letters. That means H will come here and I will come here. Okay. So by applying this rule from left to right, that means first you have to check the concept of aromaticity, then measuring effect, then resonance, then inductive. That means aromaticity, that is aromatic is more stable as compared to mesomeric. That means mesomeric and aromaticity nearly equal. But in second, resonance comes after mesomeric. Then hyperconjugation, then inductive effect. So you check here only hyperconjugation and inductive will apply. But here mesomeric is the father of all. Okay. So here Lawson effect. And here also loci or losses, that is hyperconjugation or loci. So by applying this rule, you will check the Lawson effect is more stable. That means the order will be second, then third, then third. As first, if you have 4 alpha hydrogen, it will be more stable, then third. So second one is more stable. Okay. So come to fourth question. So here in phenyl chlorine, that means here only one phenyl group is attached to carbon atom after removing the leading group phenyl carbon atom. And here at para position a electron donating group is attached. Here also at para position electron donating group is attached, that is methyl CH3. And here also a electron donating group is attached, that is NH2. So you know that the electron donating group increases the stability of carbon atom. You have to check here that electron donating group increases the stability of carbon atom. So that more will be the stability of carbon atom, more will be the SN1 reaction. So in this case, only one phenyl group is present. Here also one phenyl group, here also one phenyl group, here also one phenyl group. But here the phenyl group is attached at para position OC3. That means it is a electron donating group, and it will stabilize the carbon atom through resonance or through measuring effect. Lawson group, that is electron donating group. Here also it is a methyl group, it is also donating group, but it will stabilize the carbon atom through CH bond. That means from hyperconjugation or inductive effect. And here also NH2 group, that means here is a non pair also, so it will stabilize the carbon atom also. So here is a confusion The here also plus and here also plus m. So which will be more stable? That means you know that the electronegativity of oxygen, the electronegativity of oxygen is more than negativity. So H electronegativity of oxygen is more. So that the donating power is less H compared to nitrogen. That means nitrogen will donate more. So H the nitrogen donating power is more than oxygen. So that amine will donate more. That means the amine will stabilize the carbocation H compared to OCH3. Okay. So the order will be first B. Then comes to B. In between C and A. In between C and A. Here is donating group CH3, but here is not donating group. So that it comes after C then A. Okay. So basically, if you cannot understand this basic concept, so you have to follow the GOC, that is General Organic Chemistry. You will all the concept, the aromaticity, mesomeric, resonance, then inductive. So I also trick, I have like, so at first you have to check aromaticity and mesomeric. Aromaticity and mesomeric is the most important concept. Then it comes to resonance, then inductive. But in some cases also there is exception, I will say in upcoming lecture. So that you have to follow Amni Hospital, this is the rule, and here extend the two letter. Reduction will come here and inductive will come last. That means inductive is less. The stability of inductive effect is less. So here is also the question. Then in the upcoming session and upcoming lecture, we will do more and more. So stay tuned, stay connected, and let's proceed. Let's connect with us and make more possibilities. Okay. So thank you for today's lecture. जय जगन्नाथ।